In this series, we've been talking about the execution of the code, and we've seen some real-life examples in order to understand that closures are based on the fact that some information is apparently not available anymore. Because, as we've seen, all the variables inside of a function have been removed from the call stack once this function has been executed. And that is important to highlight because sometimes closures are confused with scopes and the scope chain, and that is a mistake, as they have their own entity and they are an independent topic by themselves, as any other one related to closures that we'll see in this series. Again, if you're familiarized with scopes and how the accessibility to variables behave inside functions and so on, you can go ahead and skip this lesson. Just keep in mind that the scope chain is just something that the phenomenon of closures uses, but it cannot be confused with closures themselves. I'm not going to dive deeper into this because this series are all about closures. So to put it simple, in JavaScript, every function has its own scope, and any function inside of another function, so a child function inside a parent function, has access to all the variables of the parent function, but has no access to the variables inside of a sibling function. It's like in one of those buildings where you can rent offices for a day. Among other facilities, let's say that every single office has its own small espresso machine. So if you want to have a quick coffee, you can use your own coffee machine inside your own office and keep working. But if there's no coffee left, you can also go to the machine on the same floor inside the break room or something. But if for whatever reason that machine has no coffee left, you can also go downstairs to the cafeteria. And even if it's one of those days and they have no coffee left either, you can always go outside of the building on the main street and eventually have your coffee. And once you've got your coffee, you can go back to your office and have it there if you like. But in any case, you cannot go inside the office next door and get some coffee, let's say. The same as someone from another office has no access to your private coffee machine, unless you're friends and so on, but you get the idea. Now, in this analogy, we can say that coffee is the value inside the variable that some function needs to execute some code. So if it cannot find it inside its own scope, it will have to go and check the next parent scope. So it will follow the scope chain until it finds that value. And if that value does not exist inside the last parent function, so the cafeteria, in this case, it will have to go to the global scope, which is in this analogy, the main street, outside of the building, to the coffee shop, where everyone has access. Now, we can understand this access as the visibility of the variables. And by the way, if you want to know more about scopes, you can check my video about var, let, const, and scopes. I'll leave the link in the description down below. But the thing is that what we need to understand related to closures is which is the path that that function must follow to access some value. And how does the JavaScript engine know that path, especially if the function has been deleted from the execution stack. Once we know all that, we'll be able to understand why the scope chain is so important for closures. In the first lessons of this series, we've used an example of closures where Kate and James order coffee twice. And to do that, they use two functions. First, they ask for what kind of coffee they like to a waiter. And in the second round, they just say that they'll have the same again and the bill, but to some other waiter. In this example, the question is, how does the other waiter know about what they're having on that table? He'll probably go and check the note for that table and will make another 2 coffees again, and will also be able to make the bill for those 4 coffees. In the same way, the JavaScript engine takes note of that, but in this case it uses objects that include references to store the information needed for not getting lost when trying to find this information, and stores these objects inside the memory heap. But we'll talk about this in the next lessons. Just keep in mind that in the case of the scope chain, it creates an object specifically for it. Now, to create the scope chain, the JavaScript engine uses what are known as lexical environments. A lexical environment is a structure that exists inside every function scope and includes the variables of that scope. And it also includes a reference to all the rest of the lexical environments of the parent scopes. So the different levels, but only a reference. The only variables and values that includes are the ones that belong to that scope, but not to that function or block, as it depends on how this variable has been declared and where. Again, it is important to understand the difference between a variable declared with var and let and const and their scopes. But anyways, during execution, Many lexical environments are generated as needed, and they will make it possible to generate the scope chain. And this scope chain, it is important to highlight that it will go only in one direction, so from small to large, and also not between sibling functions.